we'll go over whatever you need to. So, do you have anything specific you want to go over starting off?
Let me look. I haven't looked at it too in detail.
Okay. On number 6B, this like figure, there needs to be a radius here. So let's just say to be able to do that one, you have to know the radius there.
Okay.
Do you just want to start at the beginning?
Yes.
Okay. Let me grab a calculator real fast. That's one thing I forgot to get. Let's see. Oh well. I'll just use my phone, it's fine. Okay, so starting off with number 1, find the mean, median, mode, and range. So for the mean, you're just adding up all those numbers and dividing by how many there are. So let's say 5 plus 15 plus 75 plus 15 plus 6 plus 17 plus 8 plus 21 plus 24 plus 19 is 205. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I divide by 10, I get the mean to be 20.5. For the median, you have to put them in order from least to greatest. So let's see. The smallest one is 5, and then 6, and then 8, and then 2 15s, and then a 17, a 19, 21, 24, and 75. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then the median would be the number in the middle. So if you're marking them off one at a time, let's see, it would be the average of 15 and 17, which would be 16, would be the median. And then the mode would be the number that appears the most or you see the most often, which it looks like we have one mode and it's the number 15. And then the range is the highest number minus the lowest number. Highest is 75, minus the lowest number is 5, which is 70.
I have a question.
Yep.
If we have two of the modes, what do we do when it's?
You write both of them down. Or if you have 3 modes or 4 modes, you should write them all down. And then number 2 is kind of along the same lines, like when would you pick mean, median, mode as a more appropriate predictor of future data? So like in this situation, the median is 16, the mode is 15, and the mean is 20. So like the difference between 16 and 20, I don't know, it's not that big of a difference. Unless you're talking about like, I don't know, ages, like 16 and 20 is a big difference if you're talking about ages. So this set of data is skewed because of the number 75. It's a really big number that affected your mean. So if you have outliers, like big numbers, this is number 2. So outliers affect the mean, but they don't affect the median. So if you had some outliers in your data, you might want to choose the median instead of the mean. And then the time when you would want to use the mode would be, we gave some examples of this in the notes, whenever your data is qualitative, not quantitative, when your data isn't specifically numbers. So mode is used for qualitative data, which is like, what's the most common, hobby? Like you couldn't average together people's hobbies to tell what, the most common hobby is. You'd have to use the mode, like the one that occurs the most there. Or I think the other example you used was if you were grading a test, it was a multiple choice test, and you're like, a lot of people miss like problem number 4, and you want to know the what answer was like chosen the most. Like it would be like A, B, C, or D. You'd use the mode for that also. You wouldn't like find the average answer there. So that's 2. It's just mainly talking about outliers and when you would use the mode. For number 3, there's a set of data. We want to draw a box and whisker plot, tell all the stuff about it, the 5-number summary, and the outliers. So let me write down the numbers in order. So let's see, the smallest number is 5. And then 11, I think is the next smallest number. And there's 2 number 11s. And then 13. And then
There's a 12.
Oh, thank you. 12. So 12, 13, and then a 14, 17, 18, 21, 22, 24, 25, 27, 54. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So we can tell the minimum right now. The minimum is the number 5. The maximum is the number 54. And then the Q1, Q2, Q3. Q2 is the median. So for this, let me count down. It's the 2 middle numbers. I think it's number set, like the 7th number and the 8th number. You have to average them together in this case. So 17 and 18. The average of those 2 would be Q2, which is 17.5. So Q2 is 17.5. Since we didn't actually pick one of those numbers for our median, we act like when we split it to find Q1 and Q3, we still use the 17. And we still use the 18. Now, for Q1, I need to find the median of this first set. So let's see. Q1 would be 12. And then I need to find the middle of the second set of data. So if I count down to the middle, it would be the number 24. So 24 is Q3. So when I go to draw a box and whisker plot, my lowest number is 5. I'm going to draw a number line and then draw it underneath. So I'm going to count by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Okay, so that tells me this is my minimum number of 5. My maximum number of 54 is about right here. Q1, where my boxes begin, is at 12, which is way over here. Q2 is the line in the middle, which is like right here, 17.5. And Q3 is 24, which is over here. So that's like my boxes. Again, this is 12, this is 17.5, and this is 24. And there's my minimum, my maximum. And just a reminder, 25% of your data is in between the minimum and the first box. The second set of 25% of your data is in this first part of this box. 25% of your data is here, and then 25% of your data is here. The reason why they're different sizes is because the numbers are more spread out over here, whereas they're closer together here. And you can see that on your data, like 12, 13, 14, those are really close together. Whereas over here, 25, 27, 54, those are really spread out over here. So that's your box and whisker plot. We need to find the interquartile range and then use that to find the outliers and tell if there are any outliers. So the interquartile range is the Q3 minus Q1, which is 24 minus 12, which is 12. Outliers are numbers smaller than Q1 minus 1.5 times the IQR, which would be 12 minus 1.5 times 12, which is 12 minus 18, which would be -6. So do I have any numbers that are smaller than -6? No, because your smallest number on your set of data is 5. Nope. Well, yeah, it is still 5. That was the wrong 5 for this one, number 5. I'm sorry, for number 3, the smallest number is 5. Okay, so I don't have any numbers smaller than -6. That's one of my, if I did, that would be one of the outliers. Like if I had -10, that would be an outlier. The other set of outliers are numbers greater than Q3 plus 1.5 times the IQR. Q3 is 24. 24 plus 1.5 times 12 would be 24 plus 18, which is 30, 42. So do I have any numbers greater than 42? Yes, I have a number greater than 42. I have the number 54. So that tells us that 54 is an outlier. If I had like also 57, there would be 2 outliers here. It'd be 54 and 57.
I have a question.
Yep.
Do we need to know the formula for the IQR and finding the smaller than and greater than?
Yes. IQR is Q3 minus Q1, basically the size of the box right there. And then the smaller than, the greater than. If you can remember the 1.5 times the IQR, it's 1.5 less than the beginning of the box or bigger than the end of the box.
Okay.
But yeah, you need to know those formulas. For number 4, it says tell if it's likely or unlikely. So my nose is 3 millimeters long. So millimeters are little bitty tiny, which let me grab real fast because I'm going to need that in just a second. Okay, so here's millimeters right here. So 3 millimeters is that long. Okay, so my nose being that long is not likely because that is way too small. Okay, so where are we at? Let's see. There we go. So for number 4, part A, that is unlikely. Millimeters is too small. A more accurate measurement probably would be, inches, that'd be a big old nose. I mean, I guess you might have a nose that big, but maybe centimeters. That seems a little more accurate. That's a cute little nose, 3 centimeters. Okay, so centimeters is probably more accurate. Okay, for part B, the football weighed 3 quarts. Okay, so quarts, if you think about it, quarts is not a measurement for weight. Quart is a measurement for like liquid or, I guess liquid or like something like flour, sugar, that sort of thing, you wouldn't measure a football in quarts. Okay, so this is an unlikely situation because they're using the wrong, sorry, I spelled that wrong measurement. You would measure a football in ounces and pounds. There probably wouldn't even be pounds, it'd probably just be ounces. For number 5, the conversions. For part A, 960 ounces into pounds. Okay, so we know that there are 16 ounces in a pound. So 16 ounces equal 1 pound. So to go from ounces to pounds, I need to divide by the number 16. So my calculator, 960 divided by 16 would be 60. So that would be 60 pounds. For part B, this is quarts to ounces. So you need to know your quarts and cups and pints and all that sort of thing. So if you have your let's see, I don't know if you have your thing in front of you. First thing we go is from a quart to a pint, right? So how many pints are in 1 quart? Are there 2 pints in 1 quart? And then we need to go from pints to cups. So to go from pints to cups, you think how many cups are in 1 pint? And it is it 2 or 4? I don't have my thing in front of me right now. This is one I can never remember. So let me look it up.
I can look at mine real quick.
I didn't bring it with me.
Yes, I have it in my folder here. Okay.
I think it's 2.
Let's see. 2 pints and 1 quart, and then
So 2 cups and 1 pint.
2 cups and 1 pint, yes.
And then there's 8 ounces in 1 cup.
1 cup. So we are allowed to use our measurement?
No, but I'm trying to, let me see. I have the test here. I'm pretty sure I don't have any of these on the test.
Okay.
No, I mean, like I have these problems, but not the cups and pints and quarts. I don't have. It's ones that you know off the top of your head, like inches and feet and yards, or days and hours and minutes and times, or like seconds. Things that you probably already know. This is one I can never remember because is it 4 quarts and 1 gallon? Is that what the other one was? I can't ever remember which one's 4 and which one's 2. But this is not on the this specific problem is not on the test. These types of problems are, but this specific one is not.
Okay.
So to do this problem, let me make more paper because I'm kind of out of paper on this one. So if I'm trying to go from 5 quarts and I want to go to ounces, I need to start off by going from quarts to pints. So from 5 quarts to a pint first. To go from quarts to pints, there are 2 pints in each quart. So I need to multiply this times 2, and I get 10 pints. And then I need to go from pints to cups. So 10 pints is how many cups. Again, you need to multiply by 2. So 10 times 2 is 20 cups. And then from cups to ounces, I now have 20 cups, is how many ounces? There are 8 ounces in 1 cup. So I need to multiply by 8. So I get, that's 160.
Yeah.
So 160 ounces. Let's see. For C and D, that is the metric conversions. So you need to know the prefixes for all the metric stuff. So the way I learned it and remembered it was kiss her daily because divorce costs money. The K is kilo, H is hecta, D is deca, B is the base, like which is grams or liters or meters. Those are your options for the base: grams, liters, or meters. D is deci, C is centi, M is milli. So for this problem, for C, we have 320 milligrams, and I'm trying to go to grams. So it is starting at milligrams, the M, and I want to get to grams, which is just the base. So to go from milligrams to grams, I'm going to the left, 1, 2, 3. So I need to move my decimal place left 3 times. So for the number 320, the decimal place is currently at the end of it. I move it to the left 3 times. So 1, 2, 3, which should now be the number 0.320 or 320 thousandths. And that's the answer. For D, same thing. I still use the same prefixes. And then this time we're going from 2 kilometers, starting with kilometers, and I want to end up at centimeters. So I'm going to the right this time. To go from kilometers to centimeters, I have to move the decimal place 1, 2, 3, 4, 5 times. So I want to move it 5 times to the right. So my decimal place is after the 2. I'm moving it 1, 2, 3, 4, 5 times to the right. I need to put in zeros there. And that is the number 200,000 centimeters. For number 6, we need to find the area of the shaded region. So for both of these, we need to split it up a little bit. For this first one, I'm going to split it into a rectangle and a triangle. So if you wanted to redraw it, you could redraw it into the rectangle and the triangle. You find the area of both and add them together. For the rectangle, the length is 13 and the width is 11. So you're just doing 13 times 11, which is, I think, 143 times 11. Yeah, so the area here is length times width, which is 11 times 13, which is 143. Is that one? I need to add that to the triangle. The measurements for the triangle, it's base times height divided by 2. Or 1/2 base times height. So to figure out this base right here, if this whole thing is 17 and this part is 13, this piece would be 17 minus 13, which would be 4. So the base of the triangle is 4. Same thing to try to figure out the height here. This is obviously not drawn to scale, but if the whole thing here is 11 and right up here is 8, 11 minus 8 would give me 3. So this would be 3 over here. So base times height would be 3 times 4 divided by 2, which is 12 divided by 2, which is 6. And I need to add those two together to get the total area. So 143 plus 6 would be 149. And this is measured in inches. And we're doing area, so it's square inches. Sorry, I didn't see that very well. For part B, it is a square with a circle taken out of it. So for this one, we are going to find the area of the square, and then we are going to subtract off the area of the circle. So the area of the square is 7 centimeters by 7 centimeters. So 7 times 7 is 49 square centimeters. The area of the circle is pi r squared. My radius is 2. So it is pi times 2 squared, which would be 4 pi. And when you put that on your calculator, you just put pi in as 3.14. So 4 times 3.14, which would be 12.56. So my area of that shaded region would be 49 minus 12.56, which would be 36.44. 36.44, and that's centimeters squared. Okay, for 7, let me just go over a few things for measurement. And this is, Jasmine, this is not specifically for you. This is just for everybody pretty much. So I graded the measurement activity, and there were some issues with measuring with inches and centimeters and millimeters. So I just want to go over that because that is on your test. So if I'm measuring, let's say I'm measuring this piece right here, you have to start at the 0. Like you can't start at the end of your ruler. You have to start at 0 here. And so you can, it's kind of hard to see on the camera because right now it's measuring it perfectly with the 0, but on the camera it looks like it's not. Let me just draw. Let me just draw something. I think it being 3D is causing more of a problem. So I want to measure how long this is. So I want to start right here. There you go, that's better. Line it up with the 0. And then to figure out where it stops at, it looks like, I'm gonna make this a little bit longer so we can kind of see through the ruler here. So it is more than 2 inches, right? 1 inch, 2 inch. It looks like it's in between 2 and 3 here. 2 and 3 marks after the 2. So you could say either one, like either one would be fine. If you say 2 marks after the 2, how many marks total are in between 2 and 3? Some people wrote this as like 2.2 inches, and you cannot write inches with using decimals. So it would be 2, and we're saying this is 2 marks past the 2. So 2 marks past, how many marks total are there? I mean, you could count them up. There are 16 total sections in between the 2 and 3. So 2 and 2/16, or if you wanted to say it was 3, 2 and 3/16 is fine also. Here, you could reduce that to 1/8 if you wanted to, 2 and 1/8. And if you notice, like the long marks in between, that would be a half. The next longest is fourth. So this is 2 and a fourth, 2 and 2/4, 2 and 3/4, a whole. The next longest ones are 8ths, and then the shortest ones are 16ths. So that's the reason why this ended up being 2 and 1/8, because it was like not the shortest mark. If you're going to measure that in centimeters or millimeters, this is 1 centimeter, 2 centimeters, 3 centimeters. This is 1 millimeter, this one little mark here. So to measure, this is inches. I was going to measure in millimeters, again, started at 0. It looks like it is right at the middle, like halfway in between 5 and 6. So, excuse me, you could use fractions to do this if you wanted to, but the nice thing about centimeters and millimeters is that there are 10 spaces in between each number. So you can use decimals here pretty easy. So this would be 5.5 centimeters. If you're going to do millimeters, that's every single mark on the ruler. So there are 10 marks from 0 to 1. So that's 10 millimeters. Between 1 and 2 is another 10. So that would be 20, 30, 40, 50 millimeters. And it's 1, 2, 3, 4, 5. So it would be 55 millimeters. And that should also make sense because on your metric conversion, let me find that. The difference between centimeters and millimeters is just moving the decimal over 1 time. And that's what we did, was we moved the decimal over 1 time. Okay, so make sure you know how to measure with a ruler. Make sure you can measure in centimeters. Sorry, yeah, centimeters, millimeters is both on one side, and then inches is on the other side. For inches, you have to measure with fractions. For centimeters and millimeters, you can measure with decimals. You could use a fraction still if you wanted to. That would be wrong, but you cannot use a decimal for inches. Okay, so that's number 7, is measuring objects with inches and with inches, centimeters, and millimeters. For number 8, being able to find the perimeter. To find the perimeter, you're just adding up all the sides. So I couldn't really find the perimeter of this one. I mean, there is a formula to find how long this is, but it wasn't given to you. So like, obviously this problem's not going to be given to you on your test, but like this one, to find the perimeter here, you can add up all the sides here. 7 plus 7 plus 7 plus 7 would be 49, not 49, 28 centimeters. So perimeter is just adding up all the sides. The only one you can't just add up would be a circle, and that is pi times your diameter is for a circle. Quadrilaterals, that's what we went over this week, classifying quadrilaterals and polygons. So let's start off going over the polygons, and then we'll like pause when we get to quadrilaterals and go over all the quadrilaterals. So for polygons, that is a multi-sided figure. So you can't have a one-sided figure. Oh, let me zoom back out, sorry. You can't really have a two-sided figure. You can have a three-sided figure. So a three-sided figure is a triangle. And there are lots of different types of triangles. There are isosceles triangles, there are equilateral triangles, there are right triangles, there are scaling triangles, obtuse triangles. So lots of different triangles there, or types of triangles there. The next one is four sides. Four sides is, and you can just, obviously triangles, you can draw it different ways depending on what kind of triangle it is, but let's see. It's an obtuse triangle. Four sides is a quadrilateral. And there are lots of different types of quadrilaterals. There are trapezoids is one type of quadrilateral. So we have just a regular trapezoid. You also have a right trapezoid, which you should be familiar with because we use those. Those were the brown ones in the pattern blocks. This was the red ones in the pattern blocks. Okay, so we have trapezoids and right trapezoids. I can't remember, did the video talk about isosceles trapezoids? I can't remember if it did or not, but that's also one. You can also have an isosceles trapezoid. But then from there, we have a parallelogram, a rhombus, a rectangle, and a square. Okay, so parallelograms are a figure that has two parallel sides. So something like that. And then we have a rhombus. A rhombus has two sets of parallel sides, but also the sides are the same length. something like this. Not a perfect drawing by any means, but 2 sets of parallel sides, but the sides are also the same length. We have a rectangle. Rectangles have 2 sets of parallel sides. The sides are not the same length. But then you have a square. A square is like the child of a rhombus and a rectangle because it has the parallel sides. Rectangles also have to have 4 right angles. So squares have all the things from both of these. They have parallel sides like both of them. They have the sides that are the same length, like a rhombus. And then they also have the right angles, like the rectangles. So that's like the classification chart of quadrilaterals. Parallelogram is like the most vague way to talk about quadrilaterals because it has the least amount of restrictions. You just have to have 2 sets of parallel sides. And not all quadrilaterals, but most quadrilaterals have 2 sets of parallel sides. Rhombus and rectangle are a little more strict. Again, rectangle has to have 4 right angles. Rhombus has to have the equal sides, and then the square is like the baby of both because it has both of them. So one of the questions I think was on your homework is every square a rectangle? And the answer is yes. Every single square is a rectangle because squares have the 4 right angles and the equal sides. Rectangles only have to have the right angles. So saying, is every square also a rectangle? Yes, because it follows the qualifications or it meets the qualifications to be a rectangle also. It's a special type of rectangle. Is every rectangle a square? No, some are, but not all of them, because some of them don't have 4 equal sides. Okay, and then doing more polygons. We have a 5-sided one. A 5-sided polygon is a pentagon. And a pentagon has 5 sides, kind of looks like a house a little bit. 6 sides is a hexagon. And a hexagon was the yellow hexagon on your pattern blocks. 7 sides is a septagon, I believe. Let's see if I can draw that. I don't know. There you go. It's not pretty, but something with 7 sides. And 8 sides is a octagon. And usually most people stop there. Nine sides is a nonagon, 10 sides is a decagon, but you don't have to worry about all that. So that is classifying your polygons. Quadrilaterals are a specific type of polygon. It's polygons that have 4 sides, and here are options of a quadrilateral. And then the last thing was know all your area formulas. I think we kind of went over that when we did this one, but area of a triangle is 1/2 base times height, or you could write it as base times height divided by 2, same thing. Of a rectangle is length times width. What else? Circle is pi r squared. I think honestly everything else you can break up into either rectangles or triangles. Even if you had like a trapezoid, like there is a formula for a trapezoid, but worst case scenario, if you can't remember the formula for a trapezoid, you can always break it up into a rectangle and 2 triangles. So these are the 3 main ones to remember. If it's a semicircle, you just divide your area by 2.
And the square is the sides.
Yes, square is size squared, but you could, since every square is also a rectangle, you could use length times width to do a square. It's just the same number. It'd be like 5 times 5 or 7 times 7 or whatever. And then 12 is just look over your homework assignments and measurement activity. Just make sure, look at your grade, especially on that measurement activity. I actually graded that. So if you got 100 and no comments, that means you're perfect and you're awesome and you don't need to worry about it because it seems like you know how to measure. If you did not get 100, I wrote specific comments of this is what you did wrong, that sort of thing. So make sure you look over your measurement activity to see if you did anything wrong there. And then also over your homework assignments that we've done so far. But this is the gist of the exam. If you can do all of this and you just look over all your homework, you should be good on your exam.
Sounds good. Thank you.
You're welcome. For everybody who's watching this later, if you have any questions, feel free to email me and I'll get back to you as soon as I can.